Hey, we are here to review some ecology for the test tomorrow. Ecology, we're going to start with, I guess just the definition. Ecology is the study of organisms and the way they interact with their environment. Terms biosphere is every living thing on planet Earth. And this can be from 35,000 feet below the ocean all the way up to 5 miles into the atmosphere. So it's a large range. There are organisms or living things in all those different areas. Two different things to keep in mind, biotic and abiotic factors. Biotic and abiotic factors are living and non-living things. Bio meaning living. If you put an A in front of that, it's non-living. These are things or factors that organisms need for survival, whether that be living things like the things that we eat, those are biotic, or you can have things like water that we need on a daily basis, which is abiotic. And so those are the different factors that we need for life. Couple other terms, population. Population is all of the same species in an area. So if you have a bunch of bunnies, okay, in an area, this is a population. All the different rabbits in an area, this is our population. Now, population is all of the one species. We do have a term that means all of the organisms in all the different species in our area, and that is a community. So community is not just the bunny species that's in this area, it's the trees. Maybe that's a species of living thing. Maybe it's a wolf or a coyote or the grass. These are all different things. So the community is bigger than the population. So this whole thing is the community. Populations, so this is a population. You could have a population of grass, a population of wolves or coyotes. Okay. So we have populations, a bunch of them within this big community. If we move out of that, we have things like ecosystems. Ecosystems are all of the living, and now we include the non-living. So the rocks, maybe the places that are non-living, the streams that run through this area, that is all the ecosystem. And so it's all abiotic and biotic factors that are important for the organisms for living. Couple other terms, habitat. Habitat is where the organisms live. Included in a habitat is also what's called a niche. Their niche is the role that they have in their environment. Now, you and I each have a niche, and the thing I want you to remember or keep in mind is that a niche is not just, hey, the bunny is the prey, the wolf is the predator. A niche is also the other things. What else does the rabbit do? So like you and I, for instance, I have a really big, diverse niche. I'm a teacher, yes, but I'm a wife, a mother, an aunt, all different things, a daughter, all things inside that. That is my niche. It is my role in the environment that I live in or in my ecosystem. Population ecology is how things change. So it would be wonderful if these populations stayed the same way that they always are throughout time. But unfortunately, that's not that case at all. Populations can change due to lots of different factors: natural disasters, lack of food, drought, weather, habitat destruction. Humans are really bad about destroying habitats of organisms. But before we do that, let's back up a minute and talk about what would happen if we didn't have destruction, or if we didn't have too much, or if we had ideal growth. So, if you have a chart or a graph, we have time on the bottom, going that way, and we have population size on this axis. Now, if you have ideal conditions, you have lots of food, you have uh, all the organisms in an ecosystem are reproducing, and you have no death, no natality. You have lots of natality, no fatality. What's going to happen is you're going to have something called exponential growth. This is an exponential growth curve. Humans, if we remember the graph we looked at in class, humans have almost exponential growth because we have had a lot of technologies that have allowed us to live a lot longer, and we are growing really, really rapidly. So that could be a problem that we'll talk about in a little while. 4 factors play a role in growth. Obviously, birth rate, natality. You have immigration, people or organisms coming into an area. You have things like death rate or fatalities, where they will leave the population entirely, or you have emigration. Now, immigration and emigration, im starts with an I, like in. Immigration, they're coming into an area. Emigration, they're going out of. So that is kind of population dealing with just one area versus the planet as a whole. Also, the age structure determines how much growth is possible. So if your population is really old, like 60, 70 years old as far as humans go, you're probably not going to have a lot of growth. That is kind of past the point of ideal reproduction. This obviously is a very bad thing because exponential growth cannot happen unless you have really, really ideal circumstances. Usually you have something we call a carrying capacity, something that cuts off the amount that of organisms that can inhabit an area. So if this should happen, we'll see a lot of death coming up here. So a lot of times what we'll see is a line that comes up, and if exponential growth is occurring, a lot of times it'll come up, and then everything will be okay for a little while, but then it'll drop down and kind of level out right at the carrying capacity. So we know wherever it levels out, that is our carrying capacity right there. So if you're looking at a graph, you're looking where it finally levels off and stays, because that is how many organisms can be supported in that area, and that is your carrying capacity. So you have a lot of factors, plentiful, and then what happens here, the reason this is, the carrying capacity can only carry so much, as it says, because we have something we call limiting factors. And we have 2 different kinds of limiting factors. There's density dependent, I'm just going to abbreviate, and density independent. Density dependent is just like it sounds. It's dependent upon density. Density is how many organisms you have in a space. If you are tightly packed, you're going to have issues. You're not going to have enough food, you're not going to have enough shelter, you're going to compete for your resources. So that's going to be an issue later on. The other thing that you could run into problems with is disease. You know that when we're in the winter, we're all tucked inside in school, in our classrooms, we're close. A lot of illnesses go around because we're in close proximity. And so that can be an issue as well. So cuts off a carrying capacity. And then there's also things like density independent. And these are the things that are going to happen whether there's a lot of organisms in an area or not. Things like the seasons. Seasons hopefully are going to continue to go as they have been. Natural disasters. The tornado is going to hit that town whether there are a lot of people or a little amount of people. So we have human activities. Humans are just, we do what we want. We don't necessarily say, hey, there's a lot of deer over there, let's go harvest that forest. That's not how it happens. And also weather. Blizzards, tornadoes, as I mentioned before, was a natural disaster. But natural disasters can also be things like earthquakes or volcanoes that are not weather-based. Now, a lot of times, if something like this happens, some of these limiting factors come along, especially if it's like a natural disaster. Natural disasters are never something that we want to be a part of or near. But if they do happen, species can overcome them if they are able to adapt. And so the thing about adaptation is that an organism will have some kind of a pressure, whether that's being a lack of a certain type of food that they ideally ate at one time, a change in temperature, a disaster of some sort. These things happen. And so organisms need to adapt. If they're not able to adapt, they can become extinct. And it is a sad reality. But also there is some positive things. New conditions can lead to new species, new areas, ecological succession. So we can start out with an area that was cleared out because something went wrong, something happened. Maybe a fire, maybe a disaster of some other kind. And you start out with a clean slate. Usually what happens is things like primary succession, where you have a pioneer, right? Pioneer community grows in. A lot of times short grasses and shrubs, that'll be first. And then you have secondary succession, where something has cleared it. So primary is when it's just an empty field in the first place. Secondary is when something has happened, the fire, the natural disaster has cleared it. But first you have things like grasses. Then you have small shrubs. That is a horrible looking shrub, but you get my drift. So you have shrubs, then you have a little bit bigger trees, little saplings, and then you get a little bit more hardy trees moving in. And then you finally get the big deciduous trees that need lots of time to grow. And so there are stages in succession. The cool thing is that there are seed pods that have been found to travel thousands of miles to colonize new areas. And so adaptation is a real part of life, and it does happen frequently. Some things that I want to talk about in communities. Communities, remember, are biotic and abiotic factors. We have some symbiotic relationships that occur. Whenever you have organisms that live in an area, they are going to relate in some way. Whether that be something we call mutualism, where you have two organisms that benefit from each other, whether you have commensalism, which is one organism benefits and the other one isn't helped or harmed. It really doesn't mind if the other thing is there, it doesn't bother it, so it can continue to do that. You also have parasitism, where you have an organism that grows in or on another organism and feeds off of it. And this is defined as one benefits and another is harmed. And you can also have things like predator and prey relationships. Predator-prey. They depend on each other. And so those are symbiotic relationships. Genetic diversity maintains the balance between these things. One more thing I'd like to talk about is a little bit about food chains and the different organisms that you find in a food chain. So you have to start out with a producer of some sort. So a producer or an autotroph, these are organisms that are able to make their own food, usually through something we call photosynthesis, which we'll talk about a little bit more in depth later as we go through our year a little bit more. And they are eaten by consumers. In order, there are different types of consumers. This one is a primary consumer, which will get eaten by a secondary consumer, which I am abbreviating, which gets eaten by a tertiary. Now, not every single food chain is going to have each one of these. Some of them might just have a primary. Maybe they just get to the secondary level. They don't necessarily get to the tertiary, but I'm putting all of them for just the heck of it. And then you have your decomposers, which will break things down, which can kind of continue the chain. This is a food chain. It's a single path of energy through an ecosystem. Now, in nature, this isn't the way it is. There's not just one thing usually that eats a producer. So the branching out of all these different organisms becomes a food web. So everything that eats everything else, all of the different relationships between organisms. And these get kind of messy. They're not really the easiest thing. The thing to remember about this is that they are dependent upon this system. If something gets added to it that isn't normally there, if something gets taken away, that can cause major havoc. Remember to be as thorough as possible when asked about what happens or what kind of an effect an organism removal or addition will add to your food web. Different types of organisms. We have herbivores, which eat plants, carnivores, which eat meat, omnivores, which eat both. There are scavengers, which eat dead things, and then there are decomposers. Now, scavengers help in the decomposition process. They are not necessarily a true decomposer, but they look for dead things and they eat them, and then the decomposers can take over and finish breaking it down into things that our plants can take up as minerals or nutrients once again. A food chain follows the flow of energy, and a food web is all of those different things. The last thing I want to mention is a trophic level or a trophic pyramid. And so we have our pyramid here. And the pyramids have different levels. So on the bottom here, this is where we have the most energy. The last thing I'd like to mention is a trophic pyramid or trophic levels. The food web and food chains, they are things that follow what eats what, follows the path of the energy through an ecosystem. A trophic pyramid looks at the amount of energy that is transferred, and it is a little bit more visually obvious. So at the bottom we have the most energy. These are things that are the producers. They are what make their own foods. They have the most energy. Then you have the primary consumer, secondary consumer, and then you have tertiary or your decomposer up at the top. You're going to notice that each time we have a transfer of energy, the levels are going to get smaller and smaller. That's because energy is lost between these levels. 10% of it is lost between this one and this one, another 10%, another 10%. So each time something eats something else, 10% of it is lost as heat. So the things at the top will have to eat more in order to get the same amount of energy for survival. Well, that is it for ecology. I hope this helps, and I wish you luck on your test tomorrow.